Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to be laying the groundwork for proposition 3. I'm not actually going to be dealing with proposition 3 yet, but I'm going to be talking a little about what mainstream academics think and have done. So one of the sites that I found has actually gotten a little closer to realizing some of this knowledge, but in fact all they've done is they've copied these sections out of Apollonius's conics. So as you'll see on the left here, you've got an orthotome and a parabola and a cone, and it shows you all the points of intersection, which are curves, lines, and circles. Well, everything actually is a curve if it's not a point or a line. And then they go on to show you how Apollonius proved these things. And of course, this proposition here is closer to proposition 3 than the previous one, because when it says T of HK here, it means the square on HK. So HK is this line here, and you take the square on that and take it to the square in proportion to the square of ms, and it's actually equal to this ratio. Realize that in fact this is how we came to the conclusion that the general equation of parabola is y is equal to ax squared, okay, or x is equal to 4a y squared. So this is again taken out of Apollonius's conics, but the method I'm going to be showing you is a lot clearer than this. So of course I'm not saying that Apollonius wasn't a genius. He was most definitely one of the greatest geometers, that possibly the greatest, but I'm pretty certain Archimedes was right up there with him. So this is an interesting proposition or a theorem that is taken from the book of conics. So what I want to do by laying the groundwork is explain to you that unless you understand the concept of number and how the Greeks realized it, the ancient Greeks, not the modern Greeks, you won't understand how all these things work. So the first thing is that you need to realize is that mathematics is the abstract science of measure and number. You cannot observe mathematics, people, okay, because mathematics is not a physical science. It's not observable. Every physical science is observable, but not mathematics. So to help you understand these concepts, I'm going to refer you to these two articles. So the one is called Discovering the Concept of Number, A Personal Journey, and the other one is A Theory of Fractions from Book 5 of Elements. You do need to study either this one here and parts of this one, or you need to figure out a way to understand number. But I can promise you, you won't, because I'm the first to publish this information, and you won't find it anywhere else. No mathematics professor or educator has this knowledge, and I give it to you free. This is how important it is. I'm giving you this knowledge free. Okay, you have to study this very carefully. Also, you'll notice that finding a common consequence is done entirely with the geometry of similar triangles and parallel lines. So that means you can actually find a line segment that both pi and square root 2 will divide, for example, exactly, by the way. So, and you do that without numbers. So if you want to know more, you have to study the articles. Now, coming back to this proposition 3, it will seem strange initially, because we're actually measuring from the top downwards. So if for example the abscissa is such that the ordinate is always less than 1, then we have that when you take the square of the abscissa, it's actually smaller, or yeah, it's actually smaller if the ordinate is less than 1. So I'll cover that all in a later video, but I just wanted to talk to you about it. And also, what is multiplication? That is something that you need to understand. So the operators of multiplication, division, subtraction, everything, and their order is explained in this article. Very important, by the way, to understand these is to download the applets. Okay, so I think over here I have an applet that you can download. Yeah, here are the applets. So you can download both these two applets, and I would highly recommend that you do, because without these you're not going to understand what follows in the articles. You have to actually try out the examples and see, what does division mean, what does multiplication mean. You don't know what it means. You have only the wrong ideas that were taught to you by the fools in mainstream academia of the last 2,000 years, and I'm giving you knowledge that you won't find anywhere else. So if you're not already a subscriber, become a subscriber and look forward to the sequence, which is the proposition 3 of Quadrature of the Parabola. Spread this news, tell your friends and your teachers, and thank me for enlightening you by contributing at my Odyssey link, and I'll place a link to that. So that's pretty much it for now. I hope you've enjoyed this little pre-introduction to proposition 3, the correct proposition, not some garbage like Cal State University publishes, which is really just a cribbing of what's in Apollonius's conics, and they don't really know what's going on, and so there are some errors in this, so I'm just warning you beforehand. What I'm about to tell you, what I've told you in proposition 1 and 2, have never been published, and what I'm about to tell you much later is also unpublished information, and probably how Archimedes or Euclid might have seen or might have understood those propositions. So that's it. I'm John Gabriel. This is a New Calculus channel. Till next time, goodbye.